Okay, guys, so in this second video, we're talking now about measures of dispersion. So if you look at what we did last time in the first video, we were talking about measures of central tendency. That's how things tend towards the middle. And now we're kind of doing the opposite. We're looking at how things are spread apart or how they're dispersed. That's called measurements of dispersion or measures of dispersion. And we've got three of them. The range, which you might probably be familiar with. All that is, it's the difference between the largest and smallest numbers in the set. Super easy to figure out. The sample variance, this is the hard one. It's got this complicated formula. I'll just go over this one time, but after this, we're going to basically be cheating. Let me explain what it says. So, and it's actually explanation right here too. What does it mean? It says, number one, take the difference between each number and the mean. That's this portion of the formula right here. This x, these are the data values, minus x bar. I remember x bar from the last page. You saw that right over here. That's the mean, remember? So x bar is standing for the average. So what is this formula saying? It's saying take your data values, subtract the average, and then what you do is square it to make it positive. Whenever you square something, it's going to turn it automatically positive. And then you add up all those values with the big sigma, right? Add it all up. Once you do that, then you average out that dispersion, that distance. So what is it doing? It's taking the distance between each data value and the mean, making sure that's positive and adding it all up, and then you average it out over everything, how many things you had. So here, let's look at the description. It says, take the difference between each number and the mean. That's the first thing. Square each of those, add them all together, and then divide by n minus 1. Just one less than the size of the set. And then, so we have this squaring going on. So the last thing is to undo that, sort of undo it by square rooting that s squared. And what that does, it gives you this idea of distance. It gives you this idea of distance. How far are things from that mean? And this is the square root of the variance. It's the standard measurement of how data deviates from the mean. In other words, it tells you how much your data is spread out relative to the average. All right, now for the next 5 problems, we're going to return to the problems on the first page and find the range, variance, standard deviation. I'll show you how to do that with the calculator and Google Sheets. One more thing about the standard deviation, guys, is it's actually going to come into play in the next section, 14.3. Right now, we're just focused on making sure we're able to calculate it. And when I say calculate it, I really mean find it using the calculator. But after this, we'll learn about its significance in the next section. For now, just think about that's how we calculate it, and it's telling you how your data is spread apart. Okay, so what we're going to do is we're going to redo numbers 1 through 5. This time, we're going to find, what did it say? The range, variance, standard deviation. Okay, range, variance, and standard deviation. So number 1, all right, I could do this by hand, but I know no one's going to do that by hand. So what do we do instead? I'll start by showing you how to find the variance using the Desmos calculator. See? Desmos calculator has a built-in function for the standard deviation. It's called STDEV, standard deviation. Yeah, it's a short version of standard deviation. So you type that in, STDEV, and then you type parentheses with all your numbers separated by commas. And then that gives you the standard deviation. Now, as for the range you just do on your own. You look here, the biggest number is 21, smallest number is 17. So what's 21 minus 17? That's 4, so your range is 4. Now, you might be asking me now, what about the variance? What happened to the variance? Shouldn't we have done that first? And if the answer is, if you're doing it by hand, yes, you do the variance first, but we're not doing it by hand. We're doing the cheat way. And there's no built-in function for the variance. So what you do to get the variance is you just square the standard deviation. So you take that previous number and you just square it. Why would I square it? Well, because remember from your notes, the standard deviation is the square root of the variance. They're even named that way. See, S is the standard deviation and S squared is the variance. So this is S right here, this 1.58113883, which means if I want S squared, then I should just square it. Yeah. So the variance is 2.5. Standard deviation is at 1.581138883. You round that to the nearest 2 decimal places. That's 1.58. Make sure though that if you're rounding before you find the variance, that you should Keep the full thing. So don't round into the end. All right, so that's the Desmos way. Now, I'm not going to use Desmos again. I'm going to use my Google Sheet. This is the easiest way to me. And first thing I'm going to do is just clear out my, just clear out the data values that I had previously. Stop it. Sorry, guys. Just inept at using my cursor here. Okay, so number one, let's redo number one real fast. I'm going to put my values in 17, 18, 19, 20, 21. And look at the right. We're looking for the range, first of all. Oh, pops out right there. Looking also for the sample variance, and sample standard deviation. Ignore the population variance, population standard deviation. Don't worry about those guys. Focus on these. This is where you find your answers. So yeah, this extra stuff is if you take a full-on stats class, then you'll find out what those mean later. But for us, don't worry about it. Just focus on these first two values. 2.5 and 1.588. That's the same values we had before, right? And then number 2, 3, 4, 5, same thing. Yeah, super easy. 70, 81, 95, 79, 85. Right here, I see my range, variance, standard deviation. So it's just like that. Next one, same thing. 0, 1, 1, 2, 3, 4, 16. Oops. Try that again. 0, 1, 1, 2, 3, 4, 16, 21. Right there is my range, sample variance, sample standard deviation. Now, one thing to note, guys, is the closer your values are together, the smaller the variance and sample standard deviation are going to be. In this case, notice my numbers are relatively spread apart from 0 to 21. And so I have a relatively large variance and standard deviation. Standard deviation also is roughly like the average distance from that middle. Okay, next one is 1, 4, 9, 16, 25, 36. These are also pretty far apart, spread apart. So notice I have an even bigger standard deviation, bigger variance. Range is 35. That's why they're called measures of dispersion. It's measuring how far things are spread apart from the middle. Okay, now for number 5, I would actually, for this case, I would actually do the range by hand because that's easier to see what's the biggest and what's the smallest. Just subtract, right? That would just be 90 minus 40. So it's 50, range is 50, right? And then as for the standard deviation and variance, instead of having to input like 86 times and input 70 10 times, what I'm going to do is go back to that weighted mean page. Actually, I have the values from the last time I did this when I did the mean. And just look right here. It's got the standard deviation and the variance for me. For some reason, the order is opposite. I don't know why I did that. I think because standard deviation is usually the one we care more about. But same thing, yeah. Here's the standard deviation, and here's the variance. And there it is. Super easy if you use the Google Sheets. Yeah. That's all I got for you for this video, guys. See you in the next one when we'll talk about box plots and we'll talk about the 5-number summary or the quartiles. Okay, that's it.